So today I'm excited to talk to you about something that I've been messing with a lot, which is called AWS Lambda Power Tools. And so let's just kind of jump into it. So what I'm going to cover today is basically what the heck are AWS Power Tools for Lambda, and then we're going to walk through a bunch of examples of different pieces of Power Tools. This will make a lot more sense once I cover what is Power Tools, but we're going to talk about logging, metrics, tracing, parameters, and idempotency. So, every developer likes to think that they follow best practices, but I mean, the truth is we tend to take a lot of shortcuts. In many cases, that's because, well, it's not always clear what the best practices are. I'm sure that many of you have seen lots of debates about what, which are the best practices for any kind of development that you're doing. And even when there is a clear cut like set of best practices, they can often be difficult to implement. Um, hold on. There we go. It's moving ahead. So that's what AWS Power Tools for Lambda helps you with. It basically is a way of codifying best practices that AWS has determined for building serverless architectures and giving you a way to integrate those into your Lambdas. So what AWS Power Tools is basically a set of libraries that encapsulate all of these best practices that you can integrate into your Lambda. So they've basically determined a number of best practices for serverless architectures, created little sub libraries into those, and then you can add those into your Lambdas. Basically, they're very opinionated, first of all, and they're completely reusable. So it's easy to just kind of add those across your entire serverless architecture across the different Lambdas that you might have. So they're available for Python, for TypeScript, for Java, and for .NET. I will have to note here that those you don't get the exact same set of libraries for each of these languages. Python is definitely the most comprehensive of the bunch. So it includes a ton of different libraries. Java would kind of be second. It's almost on parity with Python, I believe. TypeScript and .NET unfortunately have less libraries included in them, but they do include a number of the key ones as well. So um, these are the libraries that are included in Power Tools for Python. You see, there's 16 of them right now. They cover a whole bunch of different types of things that you might need, from things from like adding streaming to feature flags to event handling, to idempotency and tracing and so on. All of these, again, are designed to be reusable, so you don't have to go and add the entire set of 16 into your Lambda. You basically choose the ones you need for that particular Lambda, and you can add those in individually. And they're designed to be really easy to use so that you can kind of configure them pretty simply. In some cases, even as we'll see, you can use middleware to kind of automatically do some of the work for you. Um, so they've created middleware wrappers that will do that for you. And in most cases, even if there isn't, they're pretty simple to implement. And the documentation is actually quite good. So today, I can't obviously cover all 16. You all don't have enough time in your morning for me to do that. So I'm only going to cover these right now. And I am a JavaScript, full stack JavaScript developer. So I'm going to be showing you to the TypeScript versions of these. And again, TypeScript is probably one of the ones that has the least number of support along with .NET. So it doesn't have the full 16, but I'm going to show you the tracer, the logger, metrics, parameters, and idempotency. Will So what we're going to talk about with each of these is, first of all, what the heck does it do? And then I'll tell you which languages are that Power Tools supports it in. And then finally, and then we're going to talk about all of my demos are going to run in LocalStack. Obviously, I work for LocalStack, so I love LocalStack, and we're going to talk about kind of some of the limitations of running these in LocalStack. I'm going to be upfront right now and say the great news is all of these work in LocalStack. So there's not one that doesn't work in LocalStack. There are just some like kind of caveats you might need to know about how they run in LocalStack, so you're aware of like how you might actually test that everything is implemented properly. And then I'm going to show you some code Uh, Obviously, like I said, this is going to be in TypeScript. I will try to run a couple of these examples. I'm not going to run every one because it gets kind of redundant. It's just basically, oh, look, it ran. But I'm going to show you kind of the key ones that I think illustrate how they work, how easy they are to implement, and also how you can use them in local stack. So the first one I'm going to cover is logger. So one thing to note, for reasons that I don't quite understand, in some libraries, like some languages, they call it logger, and in some of the others they call it logging. Obviously, it's the same thing, but you might be wondering to yourself, like, okay, why do I need a library to implement logging? This is pretty simple. I could do that without a library. The thing is, though, is that CloudWatch supports something called structured JSON. And structured JSON allows you to do things like add a kind of log level to your logs. You can even add data as JSON, and that data can then be used for searching your logs or for visualizing different aspects of your logs and things like that. And so, what Logger does is basically make it super easy for you to add this structured JSON and log levels and things like that. So it's very opinionated about how you do that, and it just makes it easy for you to add those into your um, Lambdas. It also, as we'll see, even supports some basic logging of some of the kind of context of your Lambda, so you can automatically log things like that. It's supported on all of the different languages that um, Powertools supports. And that's going to be true, honestly, for all of the ones I talk about today. I'll say ahead of time, because basically, if it's supported in TypeScript, it's pretty much supported in all of them. That doesn't go the same, say, for Python. Some of the things in Python, obviously, are not in TypeScript. The limitations for on local stack are basically like, okay, so we do have the ability to run this. It's going to run perfectly, but the CloudWatch logs on local stack on the local stack web app don't support like parsing that structured JSON. So you're not going to get the same visualizations that you might get within the AWS console. But I'm going to show that to you so you can get a better sense of how that works. I'm going to jump out of here. I'm going to jump into my VS Code. First thing I'm going to do is just to note, you'll see me using the make just to run these. Basically, all the make file is doing is bootstrapping and then deploying the different the different examples here. So I'm going to go ahead and um, make, and we're going to deploy the logger. So this is going to deploy it to my local stack that's running right now. So again, you can see I'm just using CDK local bootstrap, CDK local deploy. If you're not familiar with CDK local, it's basically local stack's lightweight wrapper around CDK so that it deploys to the proper location, which is my local version. So I'm going to go ahead and I'm going to go to the logger Lambda so we can kind of look at the code and you can see how easy it is to implement. Basically, all I did here was I imported the correct library, which is just all I want is the logger. Again, I mentioned they have middleware wrappers. In TypeScript, they use something called MIDI. This is entirely optional. You don't have to use their middleware, but I did use their middleware. And we'll get into a little bit of why I did that. So in this case, you can see I instantiated the logger here. And then I'm going to set the log level. I've actually used the default log level, but it supports debug, info, warn, error, critical, and silent types of log levels. So I'm just using the default info log level here, just to kind of illustrate how you might set that log level. I am also going ahead and actually manually passing in a log message, which is just, again, simple example message. But in this case, I'm passing in data that's data from within my Lambda. I'm going to pass that in as JSON. And I would be able to then, within CloudWatch, I'd be able to see that data, search that data, and do different things with that data. I'm also using the MIDI middleware, as I mentioned. And what the MIDI middleware in this particular case is doing is actually going to inject details about the Lambda context automatically into the log. So even if I didn't actually manually include this logging message, there would be some information automatically logged about how my Lambda was performing and passed into my log messages. So let's go ahead. I've actually deployed that to local stack. So I'm going to go ahead and go. Sorry about that real quick. I'm getting rid of that. So I'm going to go. You can now see if I go to my overview here. For those of you not familiar, this is the local stack web app. You can now see like I've got Lambda function running here. I'm going to go ahead and go into my resource browser. I'm going to go ahead and go ahead and open this logging function. I'm going to invoke it. So I'm going to I don't need to pass any payload. Oh, of course. Of course, we get an error. Demo gods, please make this work. Okay, I'm going to try refreshing this. Sometimes what happens is I have an old version that because I was testing it this morning. We're going to try it one more time. That worked perfectly this morning. So let's go ahead and invoke it. Did not. Okay. Well, I will move on. Sorry about that. Unknown error occurred. Great. This worked an hour ago. All right, so we'll move on. Basically, what you would see if this had properly invoked is that I would then be able to go into my CloudWatch logs, and I would be able to go into this logger function and see the logs where where you would see the message that I passed in into the logs here. You would see that structured JSON that I passed in. You would see here in my log messages. Again, they wouldn't be visualized in the same way you'd see in AWS console, but you would be able to verify that it is actually passing in these things properly as well. So let me go ahead and restart LocalStack so I can go ahead and show you different demos, and I'll jump back into the slides. Hopefully for the future ones, the demo gods will be with me. All right, going back, I accidentally hit the wrong button. Turning me off. Okay. So the next one I want to talk about is metrics. So as we discussed in the prior talk about logging, that CloudWatch supports this embedded. You can embed JSON into your log files. They also support something AWS calls the embedded metric format. Basically, what embedded metric format allows you to do is to include a bunch of data in your metrics in your log messages, and those metrics can then be used to visualize different aspects of how your application is performing, and you can even add alarms based on those metrics so this enables like basically real-time instant detection using just your log messages. And what the metrics library in this case allows you to do is simplifies writing these metrics into your logs in the proper format, while also even allowing you to do things like adding validation to those logs, to ensure that basically the metrics you're passing are valid for that particular metric that you're trying to track. So it is again available on all the different languages that are supported by Powertools. And the limitations on LocalStack for now is basically there. In similar to tracing, LocalStack doesn't support parsing the embedded metrics format yet. So you're not going to be able to visualize these in the same way or add like the alarms and different things like that. You will be able to actually doing similar to what I was trying to show earlier, where you will be able to go into your logs and see that the metrics are being written out in the proper format via your CloudWatch logs, but you won't be able to visualize them in the same manner you would using CloudWatch um, it, on the AWS console. So I'm just, in this case, I'm not actually going to run this, which is probably a good idea, seeing as things did not work properly for me the first time, but I'm going to go ahead and show you so you can kind of get a sense of what this looks like. Again, I'm just in this case importing the metrics library. I am going to import the middleware here. So the middleware in this, what happens with metrics is that they're added asynchronously, and basically they're not written basically as you each time you add a metric here. As an example, it's gonna dump those all in batches. What the middleware in this case will do is automatically kind of process those logs so that you don't have to worry about having to manually send those logs for processing. So you can add your metrics, and the middleware will take care of passing those metrics into properly into your logs. So in this case, I'm just going ahead and importing the middleware as well, which is that MIDI middleware again, to wrap my handler here. I am instantiating the service. You give it a namespace. So that's the way the metrics work, is they have a namespace and service name. I just kind of gave it silly namespace and service name for the case of a demo. And then we're going to add a metric. In this case, the metric can be whatever you want, and I can even add like a validation, which is kind of what I'm doing here with this metric count, metric unit count. I'm giving my metric a name. I'm adding some validation, and I'm adding a value to that metric, and that metric will then be written out into the logs. I'll be able to visualize that, even add alarms on that, and things like that. Obviously, successful run is not necessarily a particularly useful metric, but you can imagine like a lot of different metrics that you might want to add in here that then want to be able to visualize or be able to add some alarms on in case your application runs into any issues. And so, as you can see, this makes it super easy to implement this. It's just instantiating the library and adding a metric at any point you want. All right. Jumping back, and I'm going to hit the right button this time. There we go. Next, I'd love to talk about Tracer. Now, Tracer, to me, I mean, immediately I think of the Overwatch character, but unfortunately today I'm not talking about the Overwatch character. I am talking about the Tracer library within AWS Powertools for Lambda. And what the Tracer library is a way of working with AWS X-Ray. If you have heard of AWS X-Ray before, it allows you to do end-to-end tracing of requests within your AWS application. So before I kind of dig into more of the details of this, I kind of want to make sure you know what that does and why you would care. So because there's a lot of terminology involved here. So trace is within the concept of X-ray. A trace is the full end-to-end request. Within that trace, there are things called segments, and those segments might represent different aspects of your application. Like, as for example, you might have a segment that's the front end of the application, another that's the API. Depending on how the scope of your application, you might have different segments. And even within those segments, there are things called subsegments, which can represent kind of pieces of code that you want to be able to track independently. Once you've basically instrumented your entire serverless application using the metrics tool base. You can visualize everything within X-Ray, which is kind of what you're seeing here on the screenshot. So you can see it's visualizing all of the different aspects of the application, as well as tracking different metrics around the different segments and so on and so forth. So then that should give you a sense of what the tracer library within PowerTools does. It's basically going to wrap the AWS X-Ray SDK with some opinionated ways of implementing it, and then automatically add trace data for you to instrument all your Lambdas. So it just makes it much simpler. If you want to add this X-ray tracing into your Lambdas, you can do that using the tracer library. So I'm going to jump right here in to show you how that's implemented. Again, I'm not going to run this one again, but I'm going to show it to you. Not the CDK Tracer Lambda. So you can see in this case, I'm importing the Power Tools. I am actually going to, in this particular record, we are actually implementing some DynamoDB table writing. So I've got different aspects of the application that I am annotating. So as an example here, we've got the subsegment that I'm adding an annotation. This annotation is actually going to have like details that I want to be able to track, like the new ID that was created by the inserting that record into DynamoDB. I'm going to close that subsegment, and you can see also here in this case I need to actually wrap the tracer around this DynamoDB client, so that it can capture different aspects of that DynamoDB interaction automatically. So there's different wrappers like this for different aspects of your AWS application that you might be interacting with. In this case, like I said, it's just DynamoDB, so I'm doing that. Um, and that's basically it. I mean, it's relatively easy. I've now added metrics that once I'm running this Lambda, those metrics can be visualized. You'll see the segments and sub segments that were created in there, and be able to track how this Lambda is running and visualize that within X-Ray. Again, one of the limitations, which I didn't cover yet about this within LocalStack, is that uh, while X-Ray is supported in the paid tier of LocalStack, it's not the full set of APIs. It's a limited set of APIs. And then the other big thing is there is no X-Ray front end in the LocalStack web app, so you're not going to kind of get that full ability to visualize these things within LocalStack. But you will actually be able to use the AWS CLI to make calls out to X-Ray to verify that everything is functioning properly, so that you can be sure that your metrics are working properly before you fully deploy them to AWS. Okay, so in many cases, you're going to have lambdas that, I mean, pretty much in all cases, that need to access secrets or some kind of shared parameters that you'd use across your entire serverless architecture, all of your lambdas basically. And the parameters library within Powertools does make it really easy to retrieve parameters from either AWS Systems Manager, Parameter Store, Secrets Manager, AWS App Config, or DynamoDB. And I didn't mention here, but you can actually use your own parameter store if any one of those is not the one you want. You can configure your own parameter store. Some of the things it will do for you is actually make it. It'll do automatic JSON transformations. So if your parameter contains JSON data, those will be converted back and forth, for you automatically. It will cache the value for you, so to make retrieving that parameter on subsequent calls will be faster. All of that is kind of automatically built into the library for you, so that if you're wondering why I might use this parameters instead of using accessing each of these individually, that would be kind of one of the reasons why you might do this. It's supported on all the languages again, and there are no known limitations of using this on local stack. It'll work exactly as you would expect it to. But one thing I'll note is app config is only on the paid tier. So if you're using the open source version and you need app config for this, you would have to upgrade to a paid version of local stack. But things like DynamoDB and stuff like that are going to work out of the box. So let's take a quick look at the code for that. I'm going to go here. We're going to go ahead and look at parameters Lambda. Let's try this again. Let's see if this works. We're going to deploy parameters and see if we can get this working. All right. So as that's the point, I'm going to show you. It's super. This is probably the easiest one of all the ones I'm going to show you today. This is definitely the easiest one to use. All I'm doing in this case is importing the parameters. In particular, I'm importing the one I want to use. I'm using SSM. So for this particular set of parameters, so I'm only importing the SSM library. Obviously, depending on which one, if you use DynamoDB, I do DynamoDB. And then I'm going to say just call get parameter. I give the name of the parameter as it's stored in SSM. And do I want to transform it? In this case, my data is stored as JSON, so I automatically want to transform it. And then all this Lambda is going to do is return that parameter as a string. So let's see. We're going to try this again. The demo gods are going to be with me this time. I could feel it. Like I said, I did run all of these things this morning, and everything ran perfectly. But for those of you who have done presentations, you're probably well aware of what can happen. It never seems to actually. Same thing will work beforehand and then break after. There you go. Hey, this one worked. Yay. So again, very, very simple, but you can see I did invoke that Lambda, and this is the parameter that was stored as JSON being passed back from SSM and I'm able to just kind of return that here. Obviously, in most cases, I wouldn't be returning that. I'd be utilizing that somewhere in my Lambda. But for the case of example, so you could see how this works, I did it this way. Okay. Before I get there, I'm going to make sure I restart LocalStack because I got one more example I want to go through with you. Uh, and that is idempotency. So, if you're not familiar with the term idempotency, basically, it's a way of describing a function that, if called multiple times, is going to return the same result and actually won't, in this case, won't run the same. Okay, so to return the same result, but it's idempotent, meaning it's not going to affect like it's if you have a transaction, it's not going to run that transaction multiple times. Like as an example, if you have a bank transaction, and let's say a deposit, and you have a Lambda that's going to handle your bank deposit transactions. If that Lambda happened to get called multiple times with the same context and inputs, you would want to ensure that it's not going to run multiple times and actually insert multiple deposits because you want to make sure that that would be a very, very costly mistake. You'd end up giving somebody a lot of money that they didn't really have. And you could think of a lot of different examples of where you might want to ensure that if this function gets called multiple times, that with the same information, it's not going to run again. It's just going to return to you the proper results, but without actually inserting a new record because it knows that that record was already inserted, right? So that's what this library handles for you is essentially turning your functions, making your functions idempotent. Um, as you can imagine, like that's not that easy for you to implement on your own because you would have to store the context information for the Lambda that's being called in some kind of persistence layer, and then you'd have to verify that that Lambda you have the same data and context, and then make sure you can return the proper results in case that has already been run, so that you can return something valid, but you're without necessarily inserting a new record. So all of this is wrapped up in the idempotency library within Powertools. So you can convert your Lambda functions into idempotent operations that are safe to retry. And it supports DynamoDB is as its persistent storage layer, so that it stores the event data in there, and that's what it uses to verify if this is the same call being retried. So it's again in all the languages that PowerTools support, and there are no known limitations within LocalStack, so you can use this as is out of the box, even in the open source version. So I'm going to show you that. I'm going to actually go into the code. It makes it easy to run. Easy to implement. But I'm going to go ahead and try and run it. Yeah, we're going to do this. We're going to deploy Idempotency. Okay. And then while that's going, I'm gonna look at the Lambda here. So in this case, we're importing the PowerTools idempotency library. We also need to import the DynamoDB persistence layer. The rest of this is basically for interacting with DynamoDB. Um, so what I'm doing here is I'm creating an imaginary subscription that we would so if somebody's subscribing, we would not want them to subscribe many times. I'm passing some kind of uh, uh, data here to store in DynamoDB. You can see what I've done is instantiate the persistence store. So I'm telling it what the table name uh, of the persistence store my so you will have a DynamoDB table that will be my subscription payments, but there is also a DynamoDB table that handles the persistence of the context within the call of this Lambda. And then I am wrapping my handler in this make idempotent function here. So that's what's going to handle ensuring that it gathers all the context, stores those contexts, and if necessary, will return the results of the prior try of that function, as opposed to reinserting the data. So that's all that's really necessary. Really, really easy for something that I think is kind of complex if you were to try and implement it yourself. So I am going to go ahead and since I deployed this, I'm going to give it a shot and see if we can run it. You can see I've got two DynamoDB tables. One is the payment table that handles those subscriptions, and then this is the idempotency table that's going to handle persisting the context for you. I'm going to go ahead and I'm going to run the Lambda. I've got some data, some fake data here that we're going to use to run this Lambda. So we're going to call this function. I'm going to invoke it. I'm going to pass this. So I'm going to invoke that once. Hopefully this works. Yeah. Okay. Payment created. I'm going to do it again. Oh, even a third time. But now I'm going to do it with, I'm just going to change the data here and we're going to go ahead and invoke it one more time. So I'm going to go back here and I want to go into DynamoDB and I'm going to go into my payment table and view the items. And you'll see that even though I invoked that new subscription one three times, I only have one record here. Even so, I only have one record, but it returned me the proper uh, result from that function on the retries. So it didn't error out and it didn't create a new record. So that function is fully idempotent. But when I changed the data that was going into there, as you can see with subscription two, we now have a separate subscription record written in. So again, super, super powerful. This is one I definitely recommend you check out because there's so many different times you might want to use that. So that's it for my demos and for the libraries I'm going to show you today. If you want to actually look at that code, it is available on GitHub. So it's in our LocalStack samples repository. Sorry, uh, not repository, whatever. Uh, it's in the PowerScript TypeScript demos repository, or you can just click that QR code that's right there and you can go there. So I'll give you a second to click that if you're interested in actually pulling down those demos and running them yourself. Either they'll work obviously in LocalStack, which is where I showed them, but everything will also deploy to AWS exactly as is. No changes needed. So if you want the full article that goes more into detail about all of these different things than I can go into in this particular presentation, I would check out the blog post that I wrote on the LocalStack blog, which is serverless best practices with Powertools. And you can go to that URL or you can scan that QR code and read the full article and walk through the demos yourself. So that's it for me. I'm going to go ahead and exit out of here and I'm going to take questions.